Hey there, everybody. Welcome to MSP Tutor. I'm Steve Taylor, your host. Today I am joined by Ben Hathaway from Mail Protector. Ben, welcome.
Thanks, Steve.
All right. I know you're the CTO of Mail Protector. You have a unique take on email lately, probably because of your new platform, Shield, which
Mhm.
is a zero trust email security platform, which is it's fascinating because nobody else has taken the zero trust approach to email before. So I'd love to have you explain like why we're looking at email for zero trust, because email's been around for, what is it, almost 60 years. It's been around like 58 years, something like that, right?
Yeah, it's a little scary how long
Yeah, and
as a
it
technology
hasn't
that's
really changed all that much.
right.
So I think
Yeah,
your goal is to change how people think about email security.
yeah. I think whenever we build a product or a feature or kind of plan to do anything, design anything, we really like to dig into the problem that we're trying to solve. Right? If you don't
Mhm.
understand the problem clearly, you tend to kind of just treat symptoms and chase things like that with surface level um, cures, if you want to call them that. And ultimately, what was bugging me, I've been with Mail Protector 16 years now as a CTO, and over those years, there was this nagging feeling of email just feeling broken. And I don't mean broken like, the functional broken, but the use of it was broken. The intended use of it was no longer there because it was abused in so many ways. So, really what we wanted to do was get to the root of that problem. That was still lingering all those years as we continued to get better at protecting people. We still didn't feel like we were getting to the root of it. And in order to get to the root of any problem, you really have to understand it first. And understanding it kind of comes back to, like you said, it's an old technology. We need to understand the roots of it. And maybe then we can understand the underlying root problem being a trust problem. And that's what we want to talk about a little bit today.
All right. Well, I know you've got some slides. There we go. So why don't you kind of dig in, man?
Okay. Yeah. So, like I said, it's a trust problem. It's that, but it kind of manifests itself as that feeling of email being broken. And when I talk about being broken, again, I'm talking about like when you open it up, it's full of noise and distractions and threats. Hopefully not, but ultimately, you have things coming at you that aren't really the messages you want, the communication you want. It's a powerful communication tool. It allows you to communicate instantly with anyone around the world. But when you have all those distractions and interruptions and dangerous and harmful things even coming at you, uh, it makes it way less useful as a communication tool. It kind of ruins it. So again, when we set out a couple years ago to do something big, we wanted to take a real swing because Mail Protector's been around for 23 years. We know this industry very well. We know the problem very well. And we wanted to come at it differently, come at it with a fresh approach, fresh eyes. And like I said, defining that problem to begin with was key. And it is a trust problem. Anyone with your email address can get into your mailbox. There's no trust or permission required. It leads to a ton of abuse, even though that is one of the advantages of the tool, right? You don't have to know somebody to email them, but that leads to the downsides of that being, anyone can get into your inbox, including bad actors, potentially. So, really understanding that problem and defining it is important. So like you said, email is an old technology. I like to quiz people on this because was it created before or after the internet? We use it on the internet today, right? So it feels like it's a technology that was created for the internet, but it was actually created before the internet. It was created for the ARPANET, the predecessor to the internet. And why does that matter though? A little tech history lesson here for you, but why? Like, why do we care when it was created? Well, it was designed for a small closed network. Look at the nodes on this network. They are government and educational institutions. So email's security model and assumption was that there was a restriction. There was a closed network. You had to actually have permission and access to the network to be able to use email. So you didn't need filtering or security in those days because you had a closed network that was controlled and access was controlled, and knowledge of someone else on the network and their email address was another aspect of the security where you could uh, count on that as a form of protection. Well, that kind of changed when we threw that tool and that technology into this environment, right? Billions of nodes on the internet now with the internet, that being the network, it's completely open to the entire world. Well, what did that do? A communication tool that was created for. Sorry, there's a lot of background noise, Steve. Is that?
I am sorry about that.
Oh, no problem. Um, so suddenly everybody on the internet has this access to this powerful tool, and anybody else on the network, and an opportunity to get into your inbox if they just know your email address, right? It's created a problem, the problem we still have today, that trust problem. There's no control over trust or permission with email. It turned this very open, flexible communication tool into a dangerous thing that had a lot of vulnerabilities that went along with it because we took something created for one environment and threw it into something completely different, creating that trust and permission problem. And this stat, is very indicative of what we feel today. The impact of this problem is significant. You all know this. You live it, right? As security and technology professionals, protecting your customers is your job, and you see how much people are under attack, and email being the primary entry point for those cyber attacks. 90% of them, according to the latest 2024 Verizon data breach investigations report, 90% of them begin with email. That's why email security should be the foundation of your email stack. If you don't get this right, then the rest of your security stack is just playing catch up. More importantly, phishing specifically is kind of the most dangerous tactic or threat today because it is the lead infection vector. 41% of successful breaches involve phishing for that initial access. Meaning, of successful breaches, like the attempts of phishing is a higher percentage of that, obviously, but 41% when they get in, this is how they're doing it. That's alarming, but the most alarming part of this is the time element. As you can see, the average time that somebody clicks a phishing link in a phishing email is 21 seconds. That's not minutes, that's seconds. And then 28 seconds after that, they're already entering data and being phished. So you have less than a minute, less than 50 seconds even, to protect your users from these types of threat in your email. This underscores, again, the importance of the email security layer of your stack, but not just that, but doing it right. You can't be kind of going in after the fact and catching these things using some kind of mailbox or API level tool that can kind of go in and clean up the mess afterwards. That's too late. You have to protect your users up front. You have to keep those emails out of the mailbox to begin with. So simply just using an API solution that reports and maybe rips out emails after the fact and tells you, oh, look, we went and found them. Did they get them within 21 seconds? Because if not, you didn't probably prevent any bad things from happening. That's kind of a security theater sense of like, well, we found them, but you found them too late, right? You really need to do this at the perimeter. You really need to do this effectively. To effectively protect your users, you need to stop these dangerous threats and keep them out of your users' mailbox to begin with. Over the years, there have been attempts to try to solve the email trust problem, but they've failed. Looking at a few, some of these, depending on how far back your knowledge of email and some of the security methods used in email, you may learn a few because some of these are not used in practice anymore. But it's important to understand why they fell short. One of them is email challenge response. This requires an unknown sender to verify their identity before emails are delivered. Upon receiving it, from an unverified sender, the system would send back some sort of challenge asking the sender to complete a task, like clicking a link or solving a captcha, that sort of thing. Uh, if successful, the original email is delivered to the recipient's inbox. Seems reasonable in theory, right? But it has a lot of issues in practice. The list is pretty long, but it's putting burden on people to kind of jump through hoops to make the communication go through. Imagine if you had the same kind of thing with another communication medium. If you wanted to call somebody, then there was some sort of action or hoop you had to jump through. And you've seen that with some with phones, like it's just annoying, so they don't tend to stick. Kind of the same problem here, but on the security aspect of it, it's not really effective because the control still lies with the sender. If you wanted to get through this as a bad actor, you could easily just complete the task, right? A lot of attacks today are so sophisticated, so targeted, so bespoke, right? Like you're going after somebody you have knowledge of. So getting around this is pretty trivial for a bad actor. Then we kind of moved into automating a similar kind of verification with something called callback verification. So instead of putting the burden on people to take some sort of action, we figure we can make the machines talk to each other to verify the sender. And this is using the actual SMTP protocol for when you receive a message to maybe talk back to the sender server and kind of make sure it exists, to make sure the sending address exists. But again, the problems outweigh the benefits. This tactic fails to solve that trust problem because most abuse uses other people's real email addresses. So they're going to verify, right? Like that is the definition of a spoofing or an impersonation attack, is pretending to be a real person that somebody is expecting to get those emails from. So all you're really doing is verifying that the spoofed or impersonated address exists. You're not actually securing anyone again. So another failed tactic. The third one here that doesn't solve that trust problem is gray listing. Gray listing is a form of, again, kind of at the SMTP server level, purposely temporarily rejecting an email because email servers kind of follow a standard or rules based on the RFC. And the standard for a good operating email server is to retry automatically after a few minutes when you get one of these temporary rejects. And this kind of came out of the world of trying to defend against bot networks, because bots would not follow those rules. They would not act like RFC compliant email servers. So it was effective in maybe dialing down some of that, but it doesn't solve the trust problem because the control still lies with the sender on the sending side, right? If I wanted to craft an attack, I could just make my attack, try again after a few minutes. So all you're doing inevitably is delaying the inevitable in this case. And again, most threats these days are way too sophisticated for something like this to effectively do anything. But most importantly, again, none of these get to the root problem. They don't deal with the fact that the trust and permission model that email was created for, a closed network, is gone. And it was gone, 20, 30 years ago when the internet became a thing. So these all have failed. They didn't get to the root problem addressing that. And since then, we've had some more recent methods that I would call incomplete. They have some effectiveness, but still fall short of addressing the trust problem. Most likely you'll recognize these because you're using them, or at least you should be, for yourself as well as all your customers. So let's take a look at a few. SPFs, the first one, the oldest of these, sender policy framework. SPF's designed to prevent email spoofing by validating the source of the email, kind of at the network layer. You can publish a policy that says these are the networks that are allowed to send messages on behalf of our domain, and that's published in DNS. It does have its advantage. It has its advantages, and it's part of the solution. It does reduce email spoofing and phishing. You can't just send from any part of the internet and get messages through on behalf of our domain. We have some control there. It does increase trust as well. When a message passes SPF, you know it came from an authorized source of email traffic for that domain. And it
But
integrates well
the
with other security messages.
it increases
What's that?
trust, but at the same time, it also makes it so that way if somebody gets hacked, like somebody gets phished and their credentials get stolen, uh, they can still pass SPF and try and fish you, right?
Yes, yeah. So again, you're exactly right. That's why it's in effect or incomplete, right? It helps in some ways, but it's not complete. It doesn't completely establish a trust model that you can count on. So it's part of the solution, but it's not the whole solution. And its limited scope is the biggest disadvantage here. It only really verify or validates at the network level. So, like you said, if somebody's server gets hacked or account gets hacked, it's going to appear and look like it's good because it passes SPF if that's all you were to rely upon. But that limited scope is why it's only part of the solution, not a complete solution. And you know, because of that weakness in it, and threat actors, bad actors are aware of SPF. Like nobody, it's become kind of so standard in terms of email that everyone knows that they got to get around it, and they can get around it. So it's also based, one of the reasons it's easy to get around. It's in this is a little deeper in the weeds, but like emails have an envelope that you actually can't see. That is what SPF is based upon, the sender inside of the envelope that's behind the message, not the from header that shows up in your email client. So since it's based on that and that doesn't show up anywhere, a bad actor can use a valid sender with good SPF to make it appear like it's coming from a trusted source, but then they can spoof the from address to be impersonation. And that's how you can kind of get that combination of like, well, this looks like a legitimate message as far as SPF's concerned, but it's not.
And when you say email has an envelope, you're talking about the email headers, right? That you can look at
No,
them through Outlook, but no.
no, I'm not even talking about the headers. Yeah, this is like I said, this is in the weeds, so we can dive into it a little bit. But just so you understand how email works, it's the metaphor there is literally like you would take an actual message and put it inside an envelope, and then when you address it and you write the return address on there, imagine getting those but never seeing the envelope itself. Like you don't see or get the data that's left at the server level when it's received. Whatever's in that envelope, claiming for recipient, it's kind of routing information. The headers are part of the content; they're part of the letter on the inside of the envelope. So like the from is more like the signature on the letter itself, whereas the return address on the envelope is what SPF kind of looks at. In term and but again, you as the user, the envelopes kind of, if you had somebody opening your mail for you and throwing all the envelopes away and just handing you a stack of letters, that's kind of how email works. Those envelopes are data that get logged at kind of the server level while a message is in transit, but then as a user, you don't have access to it typically unless you've got some advanced type of access and server level kind of thing.
Gotcha.
So that's SPF. Like I said, limited scope. It kind of works at the network level. It does do some level of validation to prevent spoofing, but it's easy to get around. That limited scope, it creates some other issues as well, but that's really the main concerns on the security side. So SPF kind of then got another thing to complement it because, again, that works at the network level, validating the source of the message. But what about the message itself? A lot of times it can be tampered with or you know used in terms of a person impersonation attack as well. So DKIM, domain keys identified mail, is a different protocol that was introduced after SPF using an actual cryptographic signature in the message's header. So like what you were talking about, you'll see a DKIM signature is this crazy looking um, signature in a header itself, which allows you to sign and authenticate where that message came from and that it hasn't been tampered with. It's kind of a, if you had some sort of man in the middle attack where a message were to be altered in the middle, it would fail DKIM as well. They won't verify if it's been altered. It's like a wax seal, kind of old school messages back in the day that were sealed with a wax stamp. Think of it like that. If that seal is broken and something were to have changed, you would be able to tell with a failed DKIM result. But it also has that other aspect of defining where messages should come from. So it tries to build on that and kind of do message and origin or source level authentication. Does, again, help in its own way to solve parts of the trust problem. Introducing the cryptographic signatures is nice because that allows you to kind of sign that message securely and do it without those being able to be compromised. But like SPF, DKIM also has a limited scope. It only verifies the content wasn't altered and came from an authorized service. Bad actors know these exist, just like SPF. A bad actor, this is so common. They know you're going to have something looking at DKIM failures for sure. Maybe not fully denying them, but handling or scoring them differently. So they found ways around them. Many phishing emails, and remember, that's the most dangerous thing that we're seeing today. They pass both of these checks, DKIM and SPF. They'll figure out a way to make it come from an authorized source, but again, spoofing that sender on the envelope that you can't see, and then signing the message as well. So it's the most dangerous type of email, like that spear phishing, very sophisticated type of attack, is probably going to pass both SPF and DKIM. The third one here then is DMARC, domain-based message authentication reporting and conformance. Definitely a mouthful to try to say the whole full thing there, but DMARC, and this is kind of the most talked about these days, but it builds on those previous two. So you really don't have DMARC without the ones that we just talked about, SPF and DKIM. But it also adds an alignment mechanism and some reporting capabilities. So being able, the most important actual thing that it adds in addition to that is that it looks at the from header. So like you said, the person that shows up in your email client, the from header is what determines that. That's what the email client will read and show you. So when I see my message from Steve, that's coming from those headers, and SPF does not verify the from header. DMARC does allow sending domains to establish define the policy for how messages from their domains, from, like, if they show in that from header as from that domain, they should conform to whatever the policy is, how it's defined in the DMARC DNS record that's published by that domain owner of the sending domain. So that gives you, as an organization, control over anyone who, or if your domain is being used for spoofing, it gives you the ability to say, if a message is coming from us, our domain, it needs to have, it needs to come from these sources, pass SPF, be DKIM signed, and if not, then do this. And there's three options. You can actually leave the decision up to the recipient. You can tell the recipient you should quarantine messages that don't follow our policy, or you can get as harsh as to say, just reject them. Don't even give them the lighted chance to see the light of day, right? And honestly, like, most commonly, you have banks and institutions like that that are spoofed very regularly, right? You'll be hard pressed these days to find one of those organizations whose DMARC policy does not reject. That's how significant and serious those risks are if those organizations are able to be spoofed, right? So being able to define that policy is the first part. Being able to define how you should handle messages is the second part. But the biggest thing again is the fact that this is one tactic. This is one method that allows you to enforce the policy on the from header, because that is what gets spoofed and shown in the email client and tricks a lot of people when it comes to phishing attacks. But it's still limited. It's only able to identify and stop impersonation and spoofing attacks. What happens if those come from a compromised mailbox of somebody that you work with, one of your customers, right? If they are sending you the email, they're going to pass SPF. They're going to pass, it's going to be DKIM signed, valid DKIM signature. And the DMARC is going to look, or the message is going to look like it's following the DMARC policy. So you're not going to be fully protected by one of the very common abuse behaviors, which is compromised accounts sending to other people that they know.
I'm starting to feel like we're screwed. Because and I say that because SPF and DKIM are not, I mean they are, but they aren't. They're outbound protection. They're something that you set up to prevent other people from being able to spoof your own domain. And then DMARC is kind of what you set up to kind of trust but verify that SPF and DKIM were set up correctly for people that are sending to you. Is that correct?
Yeah, there's that is part of the problem there, right? Like there's a lack of agency saying like, well, now I'm dependent on everybody I want to get email from setting all these things up and following all these best practices, right?
Mm-hmm.
So
So
yeah, it can definitely feel like that. And that's at the root of it, right? Like the control and the permission and trust are in the wrong hands. They're on the wrong side of it. And again, to go back to the beginning of our conversation, it's because email was created for a world where you didn't have to worry about that, right? It was a closed network of government and educational institutions. It was very tightly controlled. You didn't need to worry about uh, the senders being bad actors and doing all these things. So you have a tool that was just created for a completely different environment. And so, yeah, like to your point, how do we take back that control? How do we, on the receiving side, know that we're doing everything we need to do to ensure that the communication we're getting doesn't have cracks in it that all these bad things can slip through? The key to solving that then comes down to just a stronger security foundation. Over the years, all these tactics have kind of chased the problem, right? SPF largely it was introduced when still bot networks were a problem. Bots being people's PCs just in their homes, in their offices, wherever around the world would get infected with some sort of malicious code that gave somebody control over that machine, and then they would use it at defined times to just blast out email from that network of computers, right? So SPF allowed you to say like, well, if it's not from these network sources, then it fails. And then so the threats evolve, but like we're just chasing the problem by attacking. And even with the incomplete tactics you saw, we layer one and then we layer another one and then we put one on top of that kind of continues to build. But again, it's that feeling of, like you said, we're kind of screwed because we just keep chasing the problem. And that's what bugged me the most over the years, honestly, was like that feeling of we're never getting ahead. We're always responding. How do we change the game? How do we take control of this problem? And that's what we really started working on 3 years ago is a completely fresh and new approach. And the first thing we started with was, I don't think we need to reinvent the entire wheel here. There are principles in cybersecurity that are proven that could be used as a new foundation. They just need to be applied correctly to email security. What what could possibly solve a problem with a trust problem? Probably something with it in its name, right? You see zero trust security as a principle used all across cybersecurity, and it's nothing new. This is a principle that's been around decades. It's at the root of all the different security layers that you probably have in place right now. Firewalls are based upon zero trust, right? You don't allow all traffic in. You only, poke holes for the types of traffic you want to permit in or out using a firewall. That is a form of zero trust. Um, you see it in EDR, you see it in all the categories at this point. It's become more and more common. So no, we didn't invent zero trust. Nobody at Mail Protector is trying to claim that. But oddly, it's missing from email security. And like I've shown you, there have been weird tactics over the years to try to apply solutions to the trust problem. But weirdly, no one's really, kind of used a zero trust first approach to an email security solution. And I think that's because it's not easy to apply it. It's essential to solving the problem, but it needs to be done right. If you don't, we use noise canceling headphones as kind of an analogy sometimes for what we want your email experience to feel like, calm with those headphones on. If you don't apply zero trust well, you're going to end up with earplugs. You're just not going to get email. And that, again, like, we don't want to kill the tool we're trying to save while we try to save it. So it's not easy to take this principle, but it can be done. And it took a lot of work to do it. But that's what I kind of want to outline just here and show you, how do you take this proven security principle and apply it to solve the email trust problem. Traditionally, email security has assumed that all email is good by default, right? And try to identify the bad messages. That's the chasing that I keep talking about. Instead, zero trust email security can assume all emails are bad. Zero trust, right? Until we have reason to trust them and a reason to grant permission to them. Trust must be earned in this model, putting the control back in your hands as the recipient, right? Again, not that we're screwed and everything's dependent on everyone else doing the right thing. But it requires several pieces to do this effectively. It's a multi-tiered approach. You can't just throw zero trust and say, hey, we fixed it. But at the foundation, you do have zero trust. But trust on what? We have to decide what we're going to trust, right? If we were using SPF, we would be basing that trust on the message source, which we've seen just by talking about it. That is not enough. That doesn't fully protect you. We could apply the trust based on something in the content. But that's dangerous because that can easily be faked, right? Especially with the rise of AI, being able to detect fake content is becoming nearly impossible. You cannot solve this problem simply by analyzing content. That's not a reliable vector. So if we can't do it at the network level, we can't do it at the content level, what are we going to base trust on? If you remember when we were originally looking at the ARPANET diagram, that closed network had control over who had access. That's what provided security. You could trust that the people and individuals on the network were allowed to email you because not everybody could get access, right? How do we bring that security of a closed network to the internet and specifically email when it's in that environment? We need to establish trust around the people and organizations you communicate with, right? That's how we turn an open network back into a closed network. But the network is your trust network, right? Let's give it a name, right? It's the network of people that you trust or don't trust. That's the essential first piece. We have to decide and find the right vector to base our trust model upon, and that's the who. In order to do that, then we need to build out the network, right? We need to build out the trust network, learn who you communicate with. This is not something that's done one point in time, right? Who you communicate with in the world is a constantly evolving and changing thing. You meet new people, new people at events and whatever. So this isn't just a one-time thing. This needs to be a living, constantly learning, evolving network that can continually dial in and be accurate about what your actual network of people you communicate with looks like. This can be done automatically, actually. See, we do not want to create a burden on users. If we did this poorly, again, to use that word, we would just kind of let the users do some manual work to tell us who you communicate, right? Like upload your contact list or something like that. Um, but again, that's a point in time thing. We need some way to automate this in order for it to be effective, as well as to encourage adoption. Anything, one of the things we do at Mail Protector with all of our products, especially something, those of you who've seen our previous products, bracket email encryption. Uh, we created the easiest to use email encryption product out there because we knew if we made it easy, your users would actually use it. We listened to partners. They were telling us, we can deploy these email encryption solutions, but then they have plugins and then they have sign-ins and then the plugin crashes or the person forgets their credentials. And ultimately they got to send their encrypted message, right? So they just revert back to using a normal email message. So they weren't protecting them in that way. And then, so one of our differences, one of the things you'll notice about us that makes us very different than the rest of this industry is we put a lot of thought and effort into usability because usage or security without usage is useless. So part of this trust network's implementation needs to be automated, needs to be automatic. But there's signals like who you send emails to and how you interact with those messages in your mailbox are data that's constantly being generated, but not by you having to do anything extra. It's just there. But we need to turn that data into something useful. Luckily, the convergence of things like the growth of AI-based technologies allow us to do that. We can process large amounts of data into meaningful insights and continue and automatically and continually turn that behavioral data into your trust network and personalize it and make it more intelligent, more tailored to you specifically. Because this is no longer an objective thing where we can build an engine that works the same for everyone. It has to be personalized. It has to be intelligent and know you specifically and your behavior specifically. So that's the kind of the foundation, right? That's how we take zero trust and put it at the foundation. We trust on the who. It's intelligent. It's constantly learning. But before we can use the who and apply that trust network to grant permission, we need to protect against some of the things we've already talked about, right? Spoofing attacks. If somebody were able to spoof somebody and then we use simply the who to grant that permission, now we have a problem. We need to ensure the authenticity of the sender we're granting trust to. Luckily, we just talked about it. We have mechanisms to do this piece of the puzzle effectively. SPF, DMARC, or DKIM and DMARC can be used to validate the authenticity of the sender. And again, it does it on multiple vectors, right? Like at the network layer, the content layer, as well as the who it's actually representing it as from in the from header. So utilizing these protocols and these mechanisms give us some keys to the puzzle at that impersonation layer. We can validate the authenticity of the sender, but there's still one more layer needed. Because we've already talked about this once, but what if somebody gets compromised, right? In this, I know you're dealing with this problem. We've seen it, we've heard it. It's a common thing. Someone gets compromised, it's a customer or a vendor, and then they start phishing or trying to communicate with the other people in the network, right? So you need a third layer here because those compromised accounts all can be the source of harmful messages. So even if we've validated the authenticity of the sender and we know they're trusted, we still have to scrutinize those messages and have accurate, effective threat intelligence to identify the kind of threats that can exist from within the network. Threat intelligence has to kind of address, it's really, we only had three spots in the puzzle to use for three words. So you see three categories up here, but the threat intelligence needs are much more vast than this. This is just the three most common, right? We need to be able to catch those threats and accurately identify them. And when those compromised accounts are sending a phishing message, they need to be captured. So being able to layer that on top will give you that level of protection. But as you've seen, as we kind of walk through this, The foundation is part of the solution. The validating and verification of the senders so we can grant permission on the who is another part of the solution. And then the threat intelligence to be able to combine these things is what creates a zero trust model for email that's complete. This is what the solution to email trust problem looks like. Being able to solve the problem fully, right? Flip the defaults, like I said. We no longer just assume by default that every message is good and look for a reason to stop it. We start with this message isn't getting in until we find a reason to let it in. And as you can see here, like it's things like, is it in the trust network? Did it pass the impersonation checks? Did it get through the threat intelligence layers? You have to get through the entire comprehensive solution to get a message into somebody's inbox. When with that trust problem solved, email can be restored to that powerful communication tool that it was intended to be. You can now safely communicate with anyone in the world instantly. 2.5 years ago, we set out, like I was saying, when we tried to define the theory around how could we apply zero trust email security, we ended up building an entirely new platform to do this because we needed to be able to integrate both the gateway level security with mailbox security in a way that was unique and novel to create a highly integrated product that took zero trust and applied it correctly to email security. And one of the things I'll mention in there that's important, and I want to point this out, going back to the 21 seconds you have, if you're not putting security at the gateway layer, and I know some people will kind of claim that API solutions are more effective. They're on the wrong side of that 21 seconds though. You have to have a gateway layer security to be able to keep those threats out of the inbox. So, being able to integrate those together was key. And that was part of why we built the Apex platform. This diagram kind of shows that, right? Even if you don't, have a gateway or your MX records pointed to a security vendor like Mail Protector, you're using a gateway. It might be Microsoft's or Google's or whoever you're using to host your email. Somebody's doing that job for you. Problem is that's not their specialty. They're not doing what they don't have the best security layer. They just have a security layer there. And if you feel comfortable telling your customers, well, we can get by with this, then fine. Like, I don't think I would feel very comfortable with, it's good enough for my security stack. And honestly, you can't chase the problem, right? Like 21 seconds. If an API-based solution is going in and ripping them out after the fact, great. That's something, but it's not a complete solution. We listen to partners over the years trying to layer these solutions in. Like, oh, the API thing kind of helps. Well, let's combine it with a gateway and we can kind of create our own solution that maybe solves this trust problem, right? But that created a mess of products to deploy and support for your users. They didn't always play nice together since they aren't integrated. So whether it's just actual, product behavior problems that introduced, or the management and cost to you internally, it wasn't a good solution. And that was, going back years, that's how we came up with Bracket. We listened to our partners first and foremost, tell us what their problems were, what they're experiencing, and then we designed to solve the problem. Same thing with this product. You need to be able to consolidate your stack, your email stack, into one trusted solution to get the job done. That solution is Shield. It's noise canceling headphones for your inbox. Shield eliminates all spam and malicious threats like phishing, but doesn't stop there. Shield stops all unwanted email. The noise you've learned to live with, to go back to what we were talking about in terms of just that email feeling broken. When you open your email and you want to send a message or whatever, and you kind of fall down the rabbit hole of distractions or potentially have threats coming at you, you have a problem at that point, right? Like you can feel it. It's the noise in addition to the threats. And the noise canceling headphones of Shield it is so effective because of that zero trust model. It literally feels the same way you probably felt years ago when you first tried noise canceling headphones and the noise of the world just went calm and everything drowned out, but you still heard what you wanted to hear, right? That's what Shield does to your inbox. You still get the emails that you want, but nothing else. You have control again. It returns that open network back to a closed network so you can actually use your email as a communication tool again without the anxiety and stress of wondering if you're going to get attacked through it, with one of those 41% of successful phishing attack or breaches coming from a phishing attack. Shield goes after unwanted email, which includes the bad stuff as well, right? Nobody wants that. So that noise you've learned to live with goes away with Shield.
You know what I find interesting is SPF was created in 2003. DKIM was created in 2007. DMARC in, what is it, 2012, 2013. And since then, there haven't really been any major new like email security protocols. There've been a few new complementary technologies like BIMI and MTASDS, but they, and I say they, I don't really know who they is, but
Right.
they haven't created any new ways of handling email security at the protocol side of things. So I see what you're doing is like you're trying to take a crappy situation and make the best out of it, right? But
Mm-hmm.
I think what really needs to happen is we almost like need an overhaul at the protocol level of how email fundamentally functions. And what you're doing is you're kind of I don't want to minimize what Mail Protector's doing, but you're putting a band-aid on this situation.
Yeah, I mean, one of the things that we can easily fall into the trap with trying to solve problems like this is maybe kind of looking at it idealistically, right? Um, Perfect world scenario, exactly what you described would be the solution, right? We all get together and agree this email technology that was created before the internet wasn't ready to handle the current environment, so let's change it. Let's change the protocol. Let's do things differently. But the reality is, like in order to solve real problems, you got to live in the reality that you find yourself in, right? And the reality of that is there's, probably billions, I don't know, at least millions, probably billions of email servers out there. You're not going to get everybody to just decide to do things differently. So you have to introduce new concepts, like you said, like SPF, DKIM. They're introduced as optional. And then eventually you get to a point where the standards become you're not going to get email delivered unless you follow best practices, right? But that takes an element of time. And what we found with Shield, or what we decided to do with Shield, was live in the reality that exists today, right? Like the only way we can truly solve this for our partners and their customers is to acknowledge the reality and then engineer around that, or through that. And build upon. That's why Shield uses things like SPF, DKIM, DMARC, uh, encryption, all the different technologies that do exist are part of the solution, but the implementation is what makes it different. The experience it creates more than anything is what makes it different than anything else out there. We didn't come up with the noise canceling headphones just as a marketing tagline. That came out of our beta. That came out of people describing what it was like to use Shield for the first time. It is that big of a difference to put this product in place in experience email in a way that you probably haven't unless you were around in those early days when the network was more closed. It's patented in several ways, as you can see from this screenshot here. There are some very unique aspects that we came to market with the features that we put into Shield, because they're designed around solving the lacking implementation details of how email works. It's an incredibly capable product, and we're just getting started. Like we we call this email's next chapter. It's the beginning of an exciting new chapter for email, we believe, because once we solve the protection and the security problem by applying zero trust, as you can see from the screen, we were able to go way beyond that, get into productivity features, giving back users time, get into privacy features, because the less the outside world, which includes all the bad actors probably going after your customers, the less they can learn about your customers, the less capable they are to craft very sophisticated targeted attacks. So privacy is also an essential part of any complete solution. That's where, giving Shield a look. Look at come take a demo with our team and see it, because until you see it, and honestly until you feel it, how would you how did people sell noise canceling headphones, right? Like, you don't do a great job of describing what it feels like. You got to just put them on and see what that calm, uh, kind of completely game changing experience feels like. And it's the same thing with Shield. So being able to experience these features firsthand is really the best and easiest way to kind of wrap your head around how big of a difference this zero trust model makes.
Very cool, man. Well, I am I'm impressed. You guys have put a lot of thought and effort into building this platform, um, and you've also put a lot of thought into uh, the existing email security protocols that you went over. One thing that one thing that I wish MSPs understood better is email headers. Um, just being able to like review them and understand what on earth are we looking at in these
Yeah.
headers. Is that something that we could get you or somebody from the Mail Protector team to come on and like go over with us sometime, because that would be huge.
Yeah, I mean, I'd be glad to, or someone from my team. Like I said, I've been doing this for 16 years, so they've become a little bit second nature to me. But I
Hmm.
do remember those early days of just looking at them like, what's going on in here?
Hmm.
They're a bit of a mess, and they only get messier because we start stuffing signatures and more things into them like this. But one of the things in Shield, honestly, to address that is X-ray. It is the name describes the feature, right? It is about seeing through the message, which is, to your point, being able to understand those headers without having to do a webinar or dig into really learning it. With X-ray, both as the administrator and the user, you can understand what's going on inside this message without needing a degree in email headers, right? So every one of those insights that we expose that's going on behind the message in a way that you can't see in your email client, we do it in plain English for normal people to understand. So you don't have to understand SPF, DKIM, DMARC, all these crazy acronyms that the email world has. You can just open your message in X-ray, and it'll tell you in plain English, this came from an unauthorized source. What's that mean? It failed
Hmm.
SPF, right? This is a forged message. It failed DKIM,
Well,
spoofing, impersonation, all those types of things.
that's great and all. And
Mhm.
again, I don't want to minimize what you guys have accomplished, but right now this only works with Microsoft 365. So,
Mhm.
like, I am a G Suite or whatever they call
Uh,
it now user.
I know.
So
You're a little envious because you can't get it, right?
I honestly am. I wish you guys had Shield for Google users, because I would be using it already.
Well, we're
Truly
working
would.
on it. The decision was made to go Microsoft first because that's where
Oh, of
most of
course.
the users are, of course. But Google is the second platform we want to support. So we're working on bringing Shield to Google as well.
And the other thing that I'm just genuinely curious about. So, obviously Microsoft users most of the time are using Outlook or Outlook for web. But what about people that are using like the Mail app on their Mac or iPhone, and other things like other third-party mail apps? Does Shield work in those other apps too?
Absolutely. Kind of building off of what I was mentioning before of how we build product, how we built Bracket. We wanted an encryption product that our users could use on any device, mobile, desktop, mail app, Outlook, whatever. We didn't want you to have to install some custom software to be able to use encryption. Shield builds upon or follows the same principle. Shield meets users where they are. And one of the ways that manifests itself is the heads-up display feature. It's a real-time dynamic interface in every message that you get, showing you the security insights at a glance, and giving you access to extra. So that most importantly, to your point, it works on your mobile device the same way it works on Outlook on desktop, the same way it works on Outlook on web or mail app on Mac or iPhone. You can stay where you're comfortable and used to using your email. Shield just
Hmm.
comes in and meets you where you are and then enhances that experience, giving you insights, giving you protection that you didn't have before.
Cool. Very cool. All right. Well, if anybody else has any questions, please pop them in the comments now. I think we're getting ready to wrap up here. Do you have any other slides or anything?
No, that's it. That's the end of this deck.
Okay.
If you want to learn more, mailprotector.com is the website. Mailprotector.com/shield will take you straight to the Shield place, or page. But you can go to mailprotector.com and learn more about our products, book a demo with our team, really kind of get a deeper dive into the product and see some of the really incredible features that we were.
Awesome. Ben, I really appreciate you coming on here and just teaching us about the history of email security and reminding us why it's so broken. I would love to see Shield in action, and I'm like, I, I'm almost tempted to switch over to Microsoft 365 just so I can use it. Almost.
I
We'll see.
I have domains that I use for my personal email, and I moved them all to Microsoft 365 hosting as we were building Shield, just so we that's how we build all of our products. We build them for ourselves first because we want to make sure that we have something useful. So
Wonderful.
I did the same thing myself.
Awesome. All right. Well, hey, thanks everyone for watching. Thank you so much, Ben, for joining me. And I will catch you next week at the next MSP Tutor. Take care, everybody.
Thanks, Steve.